Yes, ma'am. Yeah. Okay. So before we even get started, you guys have a picture of a wave on your notes. Who can raise your hand and remind me what type of wave that is? Angelo.
Transverse wave.
A transverse wave. So please write that on your paper. All right, so the first definition we're going to get out of the way is our amplitude definition. So if you see something bolded or underlined, remember you should be writing it down. So the first thing we're writing is our definition for amplitude. Bindu, can you read it, please?
A measure of how large the wave is. A measure of how large the wave is. Larger waves have more energy than small waves.
Thank you. So let's get that copy, please. So when we're measuring amplitude, we have to have something indicated on our wave. So we have to have this midline right here, because in order for us to measure amplitude, we measure from the middle of the wave all the way up to, who remembers our vocabulary word for that? Like?
Crest.
The crest, good. So you measure amplitude from the middle to a crest. Technically, then you could also measure from what? Jordan?
From the middle to the trough.
Good. He said you could also measure technically from the middle to the trough, because this is the middle of the wave, so we should be able to measure either one. Okay? So on your drawing, let's indicate that. Let's draw a little line from the middle of the wave to a crest, and then label that amplitude, so we know that's how we measure amplitude. Okay, we good? Alright. Second definition we want to get out of the way is wavelength. I'll take a volunteer to read this one. Jayla, thank you.
A measure of how far apart or close together the waves are.
Great. Get that copy. Alright, so the way that we're going to measure wavelength is we go from the top of one part of the wave to the one right beside it. So we're going from one crest to the crest that is immediately to the side of it. So indicate that on your paper. And then who could tell me what we could also technically measure from? Ashley? Can you look at louder, please?
The trough to the other trough.
Yeah, we could go from one trough to the other trough right beside it. Just make sure you're not skipping one in between for any reason, which you wouldn't really have a reason to. Okay? So, what you should be thinking now is, Ms. Kearns, this is great, but this is only dealing with a transverse wave. So how on earth can we measure these two things if we're talking about compressional waves? And there's two ways that you can, okay? So the first way, which is what we're mostly going to do today, is if there's a compressional wave, which remember is the example on the top, it moves matter, okay? And the particles get real close together and then further apart. So we can draw a transverse wave that represents that, okay? So that's one way to do it. Does anybody remember for our compressional waves what the areas of the wave where the particles are close together are called, and then the areas that are further apart, what are those called? I got 2 people that remember, 3 people. Some smiles, and no, we forgot over the weekend. Angelo.
I'm not sure, but I think the ones that are closer together is like the compression.
You are right. So when they're close together, they're compressions, and then the other one's the weirder word. Do you remember?
The rarefaction.
Exactly right. So where they're close together, we have a compression. Where they're further apart, we have a rarefaction. Okay? So then we can draw something that kind of translates that way. Okay? So if if we have compressions and rarefactions, how do we think we can get a wavelength from that? Anyone have a guess? It's okay if you're wrong. Just think about it. Jordan, what do you think?
To measure from the compressions to the other compressions.
Good job. So to measure wavelength, we're going to measure from one compression to the other compression if we're not given a transverse wave. So you guys should be writing that on your paper. Under how does this translate to a compressional wave? And amplitude, though, is a little bit different. Does anyone have a guess how we can assume or guess what the amplitude of a compressional wave would be? So this top wave, anyone have kind of a guess as to how we would look at amplitude for one of those? John, what do you think?
The amount of matter that's moved.
Good job. Did you look at my master key? So the amount of matter that is displaced is going to be the amplitude. So this is just showing kind of like a tuning bar. So in the first one, it's hit just very lightly. So it's not going to make a very loud noise. So you only have a little bit of matter displaced. So you can see that our compressions don't have a real condensed particle area. And the next one, they hit the tuning bar a little bit harder, so you have a louder noise, so more matter is displaced, so you have more particles of the medium in the compression, okay? If we're transferring then these compression waves that look like this to transverse waves, the second one is going to have a much bigger curve than the first one because we're going to have a bigger amplitude, okay? We're going to talk about sound waves a lot more next week, but just so you guys know, so quieter sounds are going to have a shorter amplitude, louder sounds are going to have much taller amplitude, and then when we start talking about wavelength and frequency, which we're talking about frequency tomorrow, the deeper the sound is, the further apart the waves are going to be, and then the higher the sound, they're going to be a lot closer, okay? So what I want you to do right now, take 30 seconds and complete that quick check on your paper by yourself. All I need is the letter that matches with the vocabulary term. Take about 15 more seconds. 10 seconds. Three, two, and one. So our first term says amplitude. Raise your hand if you can tell me which letter shows our amplitude. I'm gonna wait till we get at least 2/3 of us with our hands up because we just went over this. Thank you, Anu.
How about C?
Which one?
You said a letter, right?
Yep, for amplitude.
C.
Which one? Try again. Amplitude.
I mean E.
Go back to the room, look at your notes. We're gonna come back to amplitude. Who can tell me crest? Naima. A is correct. Can you write A for crest? Who can tell me trough? Julia G. B is correct. And who can tell me wavelength? Andrew.
C.
C is correct. And Anu, did you figure out your mistake?
Yes.
What is it?
D.
D is correct. So you should have D, A, B, C. Huh? E was to throw you off. So sometimes, and this is why I put E in there, a big mistake kids will make sometimes is we'll think that, oh, it's from the crest to the trough. So this is actually going to be what value of C? Jordan? Half, yeah. So if we go from crest to trough, that's actually going to be half a wavelength because we need to go from crest to crest, which that's going to be important when we do our next activity, okay? So now we're just going to do an out loud check real quick. I'm going to ask a question. I'm going to give you guys some time to think about it. When you think you know the answer, raise your hand. So looking at the waves on the board, who can raise your hand and tell me between wave 1 and 2, which one has the highest amplitude or the greatest amplitude? Between wave 1 and 2, which one has the biggest amplitude? Zion.
Wave 2.
Wave 2 is correct. Who can tell me Of all the waves, which one do we think has the smallest amplitude? Of all the waves, which one has the smallest amplitude? Kylie? Wave 1 is correct. Of all the waves, which one do we think has the smallest wavelength? Get on. 4 is correct. Of all the waves, which one has the biggest wavelength? Sayla? 3 is correct. We good? All right. So now you should be thinking, Miss Kearns, great. Why does this matter? Because I don't have any guesses as to times we've seen waves and it's important, or anyone talking about a wavelength, frequency, amplitude. Anyone have any guesses? Then do what do you think?
Wait, so don't you know when you like drop a rock, into like water, and then it goes deep, and then it goes like that?
Okay.
Maybe that's
So that would be an example of kind of a wave going out from the source or the disturbance. Let's get one more guess, and then I'll just tell you how it applies.
When like somebody's talking or something, like when like if somebody has a microphone or something.
Okay. Or if you think I'm yelling at you too much, be like, Miss Kearns, take your amplitude down. How many of you guys have ever looked at like a sound mixer, or you've talking to like a microphone and something like this pops up? So this is an example of we've had a compressional wave and then they've kind of transferred it to looking like a transverse wave so that we can modify it, okay? So where we have the really big spikes, we can assume that that sound is very loud, and we have the little tiny spikes with quiet sound, okay? And they can also look at pitch and frequency with that. Another big example is if we're talking about echolocation in animals, so bats, dolphins, whales a little bit, I think, but not as much as these two examples. When they give off a sound, they know what frequency they're doing it at, or the distance between their waves, their wavelength. And the way that it works is it goes until it bounces off of something, and then it comes back to them. And based off of that time, they know how far away something is, and even how big it is based off of how much sound comes back to them. Similarly, how many of you guys have ever watched a movie and you see something like this show up in like the military movie or whatever is going on? What is the sound that's normally associated with that? Beep, 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 right? So whatever is giving off that sound, it's the same thing as kind of these animals, right? It's going until it bounces off of something and then comes back to whatever was emitting the sound. They can tell how far away it is and how big it is. The last example, which I think is the coolest example in my opinion, but this could be because I was in school for some medical things before I was teaching, is how many of you guys have ever seen an ultrasound, or someone has been like, I had to go get an ultrasound. So you've heard of an ultrasound before. Most of us, right? So this is super interesting to me, and even in the name, you should know then that it's dealing with sound. But how many of you guys knew that this dealt with sound before? Or like actually thought about it? Okay, so some of you, I didn't so much. But what happens is they're playing a sound that we can't even really hear, and it's going through the belly of the pregnant woman, okay? And based off of how dense certain areas are, that sound either comes back or it takes longer to come back. So who can tell me like which part looks the most dense, like where we have the most particles that the sound was hitting off of the most? Jayla? The baby's head, which is made of what? This little part right here is all that little brain the baby has. What is this part? What's protecting your brain, Jayla?
Bone.
Skin.
Huh?
Bone.
Your skull. Your bone. So you have a forehead that's really, really dense, right? And then you can see like the little baby's ribs, ham bones and things. Why is it so dark around the baby? Blake?
Because it's like nothing else there. It's like liquid.
It's fluid, right? And so fluid isn't as dense as like solids like bone and cartilage and things like that. So the sound is traveling through that more as opposed to bouncing back. Questions?
So how come at the above the black stuff? What is that?
So that's like your uterine wall. So it's like skin and muscle and tissue and things, whereas inside of that is literally like water and the baby, and the amniotic fluid. If someone says my water broke, that's literally all that stuff coming out.
So basically, the baby is like breathing water.
Basically, we're like fish. All right, so now how we're gonna apply this, we need to go back to our objective and make sure we can measure amplitude and wavelength. Can you ask me a question, or in a second? Thanks. So we're gonna make sure that we can measure amplitude and wavelength. You guys are gonna be given some waves where you're just measuring the amplitude and wavelength, so that's kind of the easier task to do. And then we're gonna eventually get to, I'm giving you a scenario and you need to then draw the amplitude and wavelength, okay? So, just to review, if I'm measuring the amplitude of this wave, who can tell me what to do? Jordan?
So you just go from like a straight line to.
What can we call this straight line? It's in the synonym for center, kind of.
Middle.
So it's a midline. So we measure from the midline to,
The highest point.
which is called the,
crest.
good. So all you'll do is you'll look from the top to the midline. You guys, it's a little bit easier for you because you have it on graph paper. So you're literally just counting how many boxes. Each box is equal to 1 centimeter from the crest to the midline. I'm going to show you a grid here in a second of how you need to count those because some people were getting a little bit confused in the last class of how to count those. If I want to do the wavelength of this wave, who can raise your hand and tell me what to do? Can do? Speak up, speak up, speak up.
You go from one trough
Okay.
to another one.
Good. So I could go from one trough to the other, so I can measure along the bottom. Again, you guys will have boxes, or I could do what? Wait.
Measure from one crest to another.
Good. Or I can measure from one crest to the other. Okay? So this part shouldn't be too difficult for you guys. Where it's going to get a little bit more challenging is I'm going to give you parameters, and sometimes I put it in the form of a math word problem to have you guys try and use some of your math skills to figure that out. Other times, some of the easier ones are just give you what the value is, okay? So actually tell me a number between 1 and 4.
4.
All right, so we're going to make the wavelength 4, and now you can give me another number, 1 to 4. 2, and we're going to make the amplitude 2. All right, I'm going to exactly show you how to do the first one, then we're going to get 2 different numbers, and you guys are going to help me with the second one, all right? The very first thing I have to have is a midline, okay, because I can't get any of my values unless I have that starting point, all right? My amplitude is the first thing I want to do after I have my midline. My amplitude is 2, so I'm going to go up from here 1 box, 2 box, okay? After I've done that, then I can get my wavelength, which is 4, so I'm going to count over 4. Don't start counting 1 on the dot. This is what some people were messing up, okay? You go 1, 2, 3, 4, put a dot, and you can make it kind of as long as you want. I'll just go to the end of my grid, 1, 2, 3, 4, and I can't fit another one. My top is done, so this part is easy, okay? The top should be the easiest part for you. But now I got to do my bottom part of it, because remember this is just half of it, so I need the other half on the bottom. My amplitude is still going to be 2, so I'm going to put a little dot for 2, but do the crests and troughs line up?
No.
No, they're kind of staggered, right? So what I'm going to have to do is figure out half of my wavelength for the first one. So if my wavelength is 4, how much over do I want to make it? 2. And then now do I count every 2? No, now I count every 4. So I'm going to go 4 and 4. Now, try to make it curved. Some people are doing zigzag lines. It's okay, but it's better if it looks curved. Okay? So far so good?
Yes.
We're going to do one more. And then you guys, I'm going to put you into groups, and you're going to do some of your own. Julia G, give me a number. 3. And Angela, give me another number.
1.
All right. So my amplitude is 1, so I'm only going up 1. And my wavelength is 3, so I go over 3. And I'm glad somebody gave me an odd number because this makes it a little different. I'm still going to be going down only 1, but then my wavelength is 3, so it's half of 3.
1.5.
1.5. So I got to go over 1.5, and now I go over how many? 3. So that's 1, 2, 3. Notice they're all going to be in the middle if you have an odd number. 1, 2, 3, and I can't do my other one. I don't have enough room. Don't be intimidated by how good I am at drawing waves. Okay? We good? All right, what I need for everybody to do in a second is we're going to get into some different groups, and we're going to be doing a couple different assignments. So when I tell you to, You're going to need to take your note sheet and your pencil, and you're going to go to the perimeter of the room, but don't move yet. Make sure there's not a lot of stuff going on at your table. Thank you. You guys will table looks pretty good. So, listen please. As you guys go, the problems are going to get a little bit harder, a little bit harder, a little bit harder. So start with the beginning problems. If you finish the first 5, you then have challenge problems to do at the bottom. I want you to do at least one of them. If you finish and there's still time, then go on to the next one. Ask your group first if you need help, and if your whole group is a little bit confused or you're not sure if you're doing it right, then you need to talk to me. When you finish, see if your group has all the same answers, and then if you do, you're going to have a key, okay? And you're going to compare this to whatever you drew on your graph paper, and if you did it correctly, then your crests and troughs should line up, okay? I can tell if you cheated on this and just tried to draw it based off of the picture. I'll have to look in a little bit. I can tell if you cheated if you don't have a midline usually, because some people just tried to like lift this up and put dots and then connect the dots. If you see a midline, try and then check, okay? It's for you. All right. Cool. Questions? All right. So right now I need everyone to get your pencil and your paper and move to the perimeter, please. Thank you for having that transition happen quickly. Please listen for your name. I'll point where your table should be, and then move there, and then I'm going to start passing out the materials, all right? So here I need Andrew, Rosabella, Ty Lee, Matt, Julia G, Ryan, Sayla, Jenna, Tanea, Paris, Jordan, Anu, Julia H, Naima, Jayla, Angelo, Sean, Ashley, and then at this table I should have Amala, Bindu, Blake, Zion. I need you there in about 10 seconds. 7, 6, 5, 4, 3, 2, 1. All right. From me, everybody is getting a sheet that's not for you. This is for me. A sheet that has questions on it. Everyone's getting one of these. Everyone is getting one sheet of graph paper. Okay? And per group, you are getting one little bundled thing of keys. Some of you have some questions on there. You'll need to read your individual sheet in order to know what your group is doing. Okay? Once you get your stuff, you may start. Do you want to help me? Sure. We get it on a sheet of graph paper. All right. You guys. There you go. There's 2 of you. Everyone's absent from your group. Okay. You guys. Yeah. Thank you, ma'am. All right. At this point, everyone should have graph paper. Everyone should have a sheet that says their group on it, and everyone should have gotten per group 1 paperclip thing of things. Ashley. I can give out some per group, but I don't have enough for everybody. That's why you have the graph paper too. So I know if your midline isn't exactly straight, that's okay. But I want you guys to use the centimeters not on the ruler. Use the centimeters on your box.
Window sideways or long ways? Window sideways or long ways? Okay.
You guys can talk. This is group activity. Alright, so for this
No, I thought it was one. That's a hard one.
Oh, so for the first part, you have 3 waves, and then say you're just trying
What's after 8? 1, 2, 3.
then for these ones, you'll have waves 1 to 5.
I don't know if it's what.
I had that for my first one.
Wave 1, not wave 1.
Oh, you thought it was actually 1.
So happy. Just wait.
So wait, what's happening?
So that's your interpretation. How do we talk about
If this for the last one. For the final one.
We're gonna see where we are in 10 minutes, guys.
I got it.
And if you need help, raise your hand. You guys are all responsible. That's not doing it on your own. Everyone should be doing it. So pass it
I'm going to.
For the clear things or for this?
So when I buy.
We want your. Remember, you need to draw it first, though, and then do some key. Don't even look it up yet.
Oh,
Yes.
maybe done the first one, then.
If you think you did it correctly, you can check, or you can do off and check. It's up to you.
The bottom one. You don't know if you guys start half, so half of the rest. It will go down. It will still go down.
So, you're just like not curving it, you're doing a zigzag, which is okay.
I started it right here, but it messed up.
Oh, it messed up. It didn't, not you. Just try to curve it.
I think it's
I made one too. I made recently. Oh, that's cool.
Yeah, right in the middle of the box. You start, start half of whatever.
This 3?
Oh, then you're gonna start 4. 4, then
Where's the 2?
if it's 7.
Why is he reading?
7.
There's 3.
We don't have 2. Angela, you have wave 2.
No, it is a March. This one is that one right there.
So you start from
Stick it to the edge of the table.
and then you count over.
Did I do something? Oh, that's not that.
No, connect it and then you keep.
That's right. Yours just more closer together. You got all of them died. Oh, it's upside down. Julie, you had it upside down. Yours is but it's
She just so smooth.
You know why? So we're going to do 2. So amplitude of 8. What's your amplitude matched up?
the numbers are confusing. This is not wave 2, but okay.
Oh.
She got
So
wave 2.
match your crest. So your amplitude looks good because it's going down the same, but you have it not the right distance apart.
Can I hold wave 2, please?
Before you put your first dot messed up.
No, wait, you're lying. Right, unless it's just her. But it could be right.
Cause like the way.
You have 5 minutes. The in-between ones? No.
Actually, I started with 1 or 2 of that.
I mean the wave.
The distance should be exact because you have boxes.
So as towards it to this one, half of it.
Which wave are you on? 4. Twice the amplitude of wave 1 and half the amplitude of wave 1.
So it would be 8 and 4.
Which is actually the same as.
8 and 4 is the same as 2.
This one's wave 4.
2.
8 under.
Oh, 2 and 4.
And then go in the middle.
Or is it 4 for that?
So we're gonna be 1. I'm at the one.
I can't find wave 4. What? I can't find wave 4.
Oh, just why? So what is our wavelength and amplitude going to be? Okay, which is the same as this. Make sure you're doing that correctly. It's double the wavelength. Sorry, you're double the amplitude of wave 1, so your amplitude is going to be 8, and you're half the wavelength of wave 1, so your wavelength is the same as what other wave? Oh, this is good. 2 is your key. Why?
How?
2 minutes.
You did this part. It's I think I did this right. I think I did it right. Okay. What's the next one? Do you have?
It's the same.
Okay. So we draw the line.
Minute and a half.
Space because it's tall.
Take 1 more minute. If you think you're going to run out of space and would like another sheet of graph paper, raise your hand, please.
I do.
Yep.
Are these papers ours?
Yes. Also didn't have this the whole thing.
Who was this in my school?
That's why I think it's wrong.
You can just label number.
Yeah. Yes. More graph paper? Raise your hand if you would benefit from 2 more minutes. All right, 2 more minutes it is. Yeah, do you need another sheet? So, there's about a minute and a half left. You guys, we should not have to do a whole group check because you have the keys at your table. You have this last minute and a half to ask me any questions because we are going to take an exit ticket the last 10 minutes of class. The challenge problems? Yeah. What do you want to try to do?
I want to try to do this one because I want to learn how to do this one.
Let's do number 5. Alright, so the amplitude of the wave is 4 times bigger than 0.5 centimeters, and the wavelength is 1/3 of 18.
So basically,
You can write
4 times bigger than, wait, no.
so 4 times 0.5. So I think it's easy to think about money. 0.5 is equivalent to 50 cents. So if I have 50 cents 4 times,
$2.
$2. So 2 is going to be the what?
The wavelength. I mean, the amplitude.
Good. And then how do I figure out 1/3 of 18? What's of mean?
You got to divide it. You got to turn it.
I'll cut a fraction. 1/3 times 18. Like 6 or something? Yeah. So if you have 1/3 times 18/1, then you get 18/.
You're talking about, okay, you said
1/3 times 18/1.
Because if you want to divide every 3 divided by 18.
you gotta divide 18, right?
Yes. It's like 6 or something, yes.
Okay.
So 6 is
then
yours.
The wavelength is 6.
Yes.
Oh, so basically.
Yeah, and then just drop.
Okay.
Good?
Thank you.
Yep.
Mrs. Klein can help.
One, two, three.
I guess both of them said something.
Huh? Did you finish top from?
Then we got
Well, I'm getting ready to left hand, so it's kind of.
that would be like half of that right there.
Raise your hand if you got at least one challenge problem done. Raise your hand if you got 0 challenge problems done. That should be everybody else. Jordan, how much longer would you like to get 1 challenge
I
problem
just
done?
started. I'm just
So you need like a minute?
Okay, I think I did this one.
No, like
A minute
60
and a half.
seconds?
A minute and a half.
Are you? Y'all 2 more minutes?
I'm going to wait for it.
Minute and a half. No more than that.
You want to try wave 4?
We did wave 5.
Yeah.
We can try wave 4 by
Both
ourselves.
values are half the wave above. So it should be 1 and 3.
Alright, both the amplitude and the wavelength of this wave are whole, even numbers. The amplitude is half of the wavelength. Neither value is greater than 9 or less than 3.
Oh, okay.
So it's
You
not
have
greater than
1
9.
minute. I'm
and
not
it's not
having any
less
more
than
time on it. It's gonna be 1 minute.
So
If you're finished, start putting your paper clip back on the
4,
keys.
5, 6, 7, and 8.
They're whole even numbers. Okay, so they have to be even numbers. Right. Are they even numbers? So
They are even numbers.
6 or 8.
The amplitude of the wavelength. Alright, so that's 4, 6, or 8. And we can't go above past that.
The amplitude is half of the wavelength. So basically,
It's either gonna, so then we gonna it's either gonna be
I think it's 8 and 4.
2, 3, or 4.
It can't be less than 3. I think it's gonna be 8 and
So yeah. Let's try 8 and 4.
yeah. I think the
But
amplitude
the
is
amplitude
8
is 8.
and the wavelength is 4. We can check it after.
Because if it's 2, that's
Alright, I
not
need
even.
everybody's voice off in 5,
Yeah.
4,
We got like 2 more minutes.
3, waiting on a couple, 2, and 1. Please put your pencils down and stop writing. As long as you got 2A challenge problem, you met expectations. Please put everything in the paper clip right now. Put 1 person in charge of that. Make sure your name is on your white piece of paper and your graph paper. And in 30 seconds, I'm going to start collecting things and call out people to help me. Thank you, Sean, for putting paper clip on things. Thank you, group 1, they're already done. Thank you, Rosabella's group. Get that stuff paper clip. Thank you. Jordan, can you collect my rulers, please? John, can you collect these, please? And Jenna, do you want to help me? Yeah. Can you collect the papers, please?
You left them both papers?
Yeah, Jenna's getting your white piece of paper and your graph paper. I need this to happen, all of this, in the next 30 seconds. So when Jenna comes around, please give her your paper. I do not